Hello everyone, it's a good evening. Dear authors and invited guests, this is a technical session 4D and myself Richa, and this session will be moderated by me. On the behalf of the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Intelligent System, Ahmedabad, India. In this year, this conference will be uh, being organized in a hybrid mode. In physical event was held in Ahmedabad on 27th of April, and the digital event held through Zoom. That is today, 28th April. I hope this session was informative and knowledgeful through the day. In this session, we have a 10 presentation. Each presentation will be allocated 10 minutes for presentation, which means 8 minutes for presentation and 2 minutes for question answer. After 7 minutes, I will raise a gentle reminder to conclude the presentation. And in this session, I have one more request. Kindly stay connected till the closing remarks. And if you have any query and any update, write it to me in a chat box. Just before we get started, I would like to introduce our chair of this session, Professor Swati Nikam. Professor Swati Nikam, she's Associate Professor in a Pimpri Chinchwad College of Engineering and Research, India. She has completed PhD from SPPU Pune. Her research area are cyber, physical system, information security, Internet of Things. Welcome to you, ma'am. Now we have started with the first presentation. Our first presenter is Vaidehi Sinha to present her paper on analysis of genomic selection methodology in wheat using machine learning and deep learning.
Okay. So, good evening, everyone. I am Vaidehi Sinha, a third-year undergraduate student at MIT World Peace University, and I'm here to present my paper titled Analysis of Genomic Selection Methodology in Wheat Using Machine Learning and Deep Learning, with authors as me, Vaidehi Sinha, and Professor Sharmishta Desai. We'll be looking at the following topics in the course of our presentation. So starting with introduction, what is genomic selection? Plant breeding is a crucial element of making sure that there is a steady supply of food for the increasing population of people, which is forecasted to rise to 9 billion by the year 2050. So genomic selection corresponds to the use of genetic markers that are distributed throughout the whole genome to link the equilibrium of all quantitative trait loci or QTLs that contain at least one marker. By summing the impacts of all these markers, GS aims to capture the overall additive genetic variation that results from these QTLs that affect the trait variability. By using GS, we can predict the traits of an unobserved population by observing and understanding the traits of an observed population. GS has become a prevalent method in plenty of animal and plant breeding programs because of the reduction in the cost of genotyping. GS has a lot of potential to provide in the field of agriculture by improving the breeding of plants by acting as an essential catalyst in the agricultural methods of programs. Moving on to what is machine learning and deep learning. So machine learning ML is a method to develop computers that get wiser as they acquire useful experience. Deep learning DL, on the other hand, is responsible for teaching computers to understand and learn in a way that comes naturally to us humans, that is to understand an example and implement it. What you're looking at right now are the two major kinds of genomic selection, multi-trait and uni-trait. In very simple terms, MTGS multi-trait considers multiple characteristics when predicting traits, while UTGS considers just one trait. Breeders have recently embraced MTGS models due to the need for prediction of numerous characteristics at once and possibility that their combination might increase forecast accuracy. When we consider UTGS and MTGS model for something called as GBLUP, which is a conventional method of genomic selection, for grain yield, which is a trait in wheat, then the prediction accuracy was higher for MTGS models by about 28%. So comparing the three major techniques that are used to perform the selection of genomes, we have already covered genomic selection. I'll explain MAS. MAS stands for marker assisted selection. In MAS procedure, a characteristic of interest is chosen based on a marker that is associated with it rather than the actual trait. While PS is when individuals with certain characteristics produce more surviving offspring than individuals with other characteristics. When the performance of prediction using GS for wheat was compared with MAS and PS, then GS had a higher accuracy by 28%, then MAS 95%, then PS for predicting the relationship between the expected and the actual value. Covering the factors that affect GS. So first is population relatedness. One of the common conclusions that we came across after reviewing the papers was that GS model accuracy rises as population relatedness does. A larger training population reduces bias and the variation of the marker effect, which increases prediction accuracy. Factors such as yield and protein content of the grain are highly regulated by a great number of QTL. One of the studies referred showed that the inclusion of markers performed significantly made the performance better by a margin of 8 to 36% when compared to a model that was based on predicative ability in pedigree. And lastly, in order to maximize genomic selection in wheat, it appears that the marker density and population structure are closely related. Moving on to the various architectures that we have covered in our literature review, they fall into two major categories, parametric and non-parametric. Parametric models are those that require the specification of some parameters before they can be used to make predictions, while non-parametric models do not rely on any specific parameter settings, and therefore they often give more accurate results. The graph on the screen shows the models that were studied and the categories that they fall in. Covering the first model, GBLUP, also called Genomic Best Linear Unbiased Predictor. It is a conventional model. It assumes that all markers are equally responsible for the trait of interest and employs a genomically estimated connection matrix with similar variation across all markers. Next up is random forest. It's a non-parametric model which is categorized in the supervised machine learning method and has demonstrated that they are capable of identifying connection between the markers. Moving on to the penalized regression model. This is one of the most frequently employed models in this domain. It estimates and penalized regressions are obtained as the answer to an optimization problem that balances the model complexity and the model quality of fit to the training data. Moving on to the Bayesian model. It considers the various different prior distributions. That is, it considers the posterior probability of an estimate, which in this case would be the concerned phenotype. And to model the whole additive variance and forecast breeding values, Bayesian techniques might be utilized. Next up, we covered in our literature review was the support vector machine. So SVM transforms the input space into a feature with a high dimensional space by using association between phenotypes and marker genotypes. SVM offers flexibility for model fitting since it allows for a set amount of acceptable model error while fitting the best regression line. Association between phenotypes and marker genotypes is thus used by SVM. Next up is convolutional neural network, also called as CNN. It is particularly effective at capturing the link between space or spatial and time or temporal of the input, and they are very potent tools for completing visual recognition tasks. The last model that we covered in our review paper was the MLP or the multi-layer perceptron. It is a feed-forward neural network that is highly linked and often does not presume a certain structure in the input characteristic. With genomic selection, a predefined number of SNP markers from the training set correspond to each neuron in the layer. As no assumptions are made regarding the combined distribution of inputs and outputs, MLP is generally flexible. And I've presented here a brief summary of all the models that were covered and the categories that they fall in. All these values are taken from the various studies that we performed as a part of our review paper. And it's a common measure that we use to compare the models, which is Pearson's coefficient. So in terms of prediction performance, DL models generally outperform all other models when multiple traits were considered. The ML models proved to be less computationally intensive as compared to GBLUP, the conventional method. The finding also demonstrated the necessity of doing genomic selection at the first stage of the wheat breeding program, because that would ensure that we have data from the very beginning life cycle of our wheat plant. If the procedure is built out every year, then the amount of data that we gather towards the end of it is going to be immense and helps us improving the prediction accuracy. Talking about the potential of machine learning and deep learning, the first point would be that its results suggest that the use of deep learning models in breeding programs get marginally enhanced accuracy of prediction. So even something like small improvement in the same might increase the efficacy of the breeding program selection. We also discovered that the use of deep learning based techniques is practical and encouraging in terms of enhancing the accuracy for prediction of complex characteristics in spring wheat, despite the computationally demanding and difficult nature of the training of deep learning models. Moving on to the conclusion of my presentation, so it is clear that sophisticated deep learning networks are necessary for highly quantitative features, since grain yield and grain protein content require more hidden layers than the other three variables. Overfitting is something that happens quite often in deep learning models because it fails to recognize broad patterns in the data. And that is the main problem that is present with short data sets. And hence, a minute ago, I mentioned that if the data is taken every year on the wheat breeding cycle program, then that ensures that we have a huge amount of data from every cycle of the wheat plant. We found that the DL model's prediction accuracy was dependent on the trait and increased with inclusion of more predictors, that is the markers that we just talked about. This paper, along with other studies conducted previously, aim to shed light on the importance of the potential that machine learning and deep learning techniques carry to improve genomic selection and make it more efficient by increasing its accuracy in less performance time. And with that said, I would like to conclude my presentation. Thank you so much for listening. Hello.
Yeah, by the way, thank you for the nice presentation. My question is, did you find in this survey any parameters, I mean, any exceptional parameters which might hamper this selection or whatever you are predicting?
So the report that we conducted, it was to predict genomes. Now, genomes are the things that are used to determine the quality of the plant, how it would turn out to be. So genomes are usually affected by the very natural factors that we consider would affect the plant, which would be infestation. It can be insects, it can be the way they interact, or its immunity. So if these factors aren't considered, if we look at just the positive part of the genome, the positive thing that make the genome selection easier, then it can hamper the model. We need to consider something that would, be inversely proportional to it in a way.
Do you think to a significant amount they affect it? Do you need to consider it?
I'm sorry, your question is clear. Hello, ma'am. Can you repeat your question?
Yeah, I'll repeat my question. Like the factors you said, which are, so do you think they are significant? They are important to consider? What is your opinion?
As I said, there is genomic selection. There are things that are directly proportional to a thing like, if they increase, the genome's importance increases. But then there are certain things which, when brought in, are inversely proportional to it. So if they increase, it sort of decreases the value of that particular genome. A lot of the studies that we came across usually focused only, for example, if I consider grain yield, the amount of water that would be put in, how does it affect the genome at a very minute level? A very positive factor to talk about. But if I consider something like its immunity with respect to pests, or with its immunity with respect to the infestation that takes place. So if these things are considered, I believe that takes place takes care of both the sides of the coin, and how all the factors that are present in the environment of a grain are affecting one particular gene. So yeah, even the negative aspects, even the things that can hamper its ability to actually be useful to the plant, to be something that should be considered for the coming generation, and even those things should be brought in as a fact. Hello?
Hello, I think chair has some technical issue.
Okay.
Oh, thank you so much, Vedi, for a nice presentation. Now we have moving ahead for next presentation. The next presentation is Chaitanya to present his paper on comparative study of transformer and LSTM network with the attention mechanism on image captioning. Chaitanya, I think he's not joined yet. We can call our next presenter, V. Mohan, to present is a paper on detection of UDP SYN flood DDoS attack using random forest machine learning algorithm in a simulated software defined network. I think he's also not joined yet. We can call our next presenter, Pavan Kumar Sanjay.
So I can start screen sharing, right?
Sure.
Good evening, everybody. My name is Pankama Sanjay, and I will be presenting the paper topic, heart disease prediction using supervised learning. We first come to the introduction. In this paper, we analyzed heart rates of the different patients using numerous time domain parameters, along with frequency domain parameters. Algorithms like logistic regression, support vector machine, decision trees, and Gaussian naive Bayes, and so on, were used in this in this machine learning project. These are a set of papers that we had referred to study this. A lot of them are based on ECG and machine learning models like support vector machine. As a lot of them for this particular topic, a lot of authors for this particular topic have used these algorithms and these techniques to train their data set. We have taken 6 papers, and these are the best papers amongst our collection of 20 that we have gathered. The next is we're coming to the objective of this project. The objective was to predict whether a person had a heart attack or not. We had chosen this topic specifically because heart attack covers a variety of diseases which can be related to the heart and so on, because there are a lot of conditions that happen when a lot of conditions that take place when a heart attack happens. In this model, we use 13 different variables in an attempt to predict this, and these attributes are mentioned on the screen, as you can see. Moving on, this is our training process. This is how we actually trained our entire data set. Starting off, we had studied different papers and also their data sets to see what we can borrow. And then we moved on to data extraction and data analysis, along with attribute selection. We finally decided on those 13 attributes for our model. And moving on, we used different models, calculated their efficiency, and the best model will be a submission for this paper. These are the algorithms that we had used in this paper. This includes logistic regression, support vector machine, decision trees, Gaussian naive Bayes, multinomial naive Bayes, gradient boost classifier, k-nearest neighbor classifier, random forest, and the random forest algorithm. Amongst these, logistic regression is mainly used for classifying categorical data. We can classify our data points into different attributes. Support vector machine takes a hyperplane. In this model, we take a hyperplane which is composed of the many outliers of our data set and try to classify our data points into different categories. Decision trees uses various kind of impurity calculation methods and also uses the tree data structure to construct to give us the best predictions. Gaussian The Gaussian naive Bayes is deals with probability calculations, and in this case, we make sure that each parameter is not related to each other in terms of any formulas or math in any way. We take them as independent parameters and we operate. And it's the same thing with the multinomial naive Bayes. Moving on, we have k-neighbors classifier. In KNN, what we do is we classify with we classify different data points based on their distance. And finally, random forest algorithm is a better version of decision tree in which we choose the best trees and try to get us the best predictions / output. So these are the results of our training process. As you can see here, random forest classifier and k-nearest neighbor have come up with the best accuracies, the best models in terms of accuracy. And if we go down here, we can see the different accuracies in terms of decimals. And if you multiply this by 100, we get that random forest classifier has an accuracy of 93%. And approximately, and k-nearest neighbor has an approximate percentage of 91.8%. Moving on, to explain our best algorithms. In this case, you can see here the precision values. What we define as precision is the number of times we have been able to predict a data point correctly. While accuracy describes how accurately we will be able to predict for that specific data point. Precision defines how far and how many times have we been able to do it. And out of the times, 93% of the times we have been able to predict whether a person has heart attack or not. And 91 when a person doesn't have heart attack, and 91% of the times we were able to predict whether a person had heart attack. Similarly, when you move to random forest, when we were able to predict easily when a person didn't have heart attack. It was 96. It happened at least 96% of the times, and when 91% of the times we were able to predict a person with heart attack. We move to a conclusion. With this system, we are one step closer in being able to identify heart diseases with artificial intelligence. According to our studies, the random forest algorithm and the k-nearest algorithm work the best, and we will use this when we are considering our future scope. The analysis can contribute to the development and commercialization of a universal system to predict heart diseases. A future scope would involve working more on the hardware side of this project and try to commercialize the system in a way so that it's convenient to use. These are the references we used for the papers. These are the 6 best papers out of our collection of 20 papers that we researched. Thank you.
Ma'am, any question regarding this presentation?
Yeah, I have one question, Sanjay. So you have listed few parameters, like, okay, in the first or second slide maybe. So what do you think, which are the most affecting parameters you found in this survey?
I would say mostly the most affecting parameters would be the ECG values directly, and also values related to the ECG signal. For example, when I showed you that particular slide, you would notice there were 2 parameters like ST depression and ST slope. These are very much related to to the different chambers of the heart, and these play a very important role in predicting heart attacks. These would be the best parameters.
And the methods which you have compared, I mean, have you implemented it or you have taken it directly from the study of other researchers?
No. We have implemented this in a particular code, and I showed you the results before. These were the accuracy results, and we'd implemented this for all algorithms that I had just shown to you. But we'd only chosen the best algorithms for this presentation.
Okay. Thank you, Sanjay.
Thank you.
Now we can call our next presenter, Deep Sahane.
Hello, ma'am.
Dear presenter, you may please start your presentation.
Yes, ma'am. Good afternoon, everyone. So myself, Deep Shahane. I am presenting the paper on intelligent process automation for Indian car sales forecasting using machine learning time series algorithms. So as we can see, the accurate demand for forecasting is perpetual requirement for the automotive industry this year. And there is a growing requirement and the demand from the public for the automobile these days. And time series forecasting is the forecasting we use by the taking the historical data and implementing it to machine learning model. As we can see, we have implemented RIMA, LSM, and FP Profit for the car sales forecasting. And for the manufacturer side, we have also implemented one system that will help him to grasp the condition of the current scenario and the future forecasting as well using multiple graphs. We will see that on the upcoming slides also. And the next part is the introduction, where, as I said earlier, the car industry is growing day by day, and the car manufacturer faces that problem. And not only him, but the customer waiting time is also increasing day by day. We can see that the normal waiting period for the Maruti company is around 4 months. But if you take a particular model like Desire, so the waiting period of that model is around 12 months. So it is increasing vastly. And to reduce that, our system helps manufacturer to predict the forecast for the future 1 year, such that the inventory can be managed accordingly and the waiting time can be reduced as a result. And this is the overall idea of the research paper, using three models such as FP Profit, LSM, and ARIMA. And now the methodology, the algorithms we used in the research paper, and we have also implemented it in the real-time system. LSTM, ARIMA, and FP Profit. Among these, we got the best result in the FP Profit with around 5% of error rate only. And the ARIMA is the second highest, and LSTM was the least accurate among the all three. Next one is the flowchart for the ARIMA, where we can see the ARIMA takes the data, like ARIMA consider the forecasting data which consider the date and the sales of the cars and like particular manufacturer. And but it is, if it's not stationary, then ACF uses that to convert that data into stationary data, and also using PACF, they convert it to their particular requirement, such that using the parameters PDQ, which are required for the fitting of the particular model, or to hypertune the parameter, we use that. And after that, we will get a required result in the particular model. And the following, that is FB Profit, where we take the time series data, and again the time series requirement for the time series forecasting is we need the date and the sales of that particular model or particular manufacturer if we consider it. And after calling, we use that to call the function called profit function, but not only that part. Adjusting the hyperparameters, like what we say tuning, is also really important in this, since accuracy is increased by a lot due to that. And this in the end, we visualize the forecasted graph using the forecast function. So that was the whole point of using the FP Profit, since it gives the three parameters: the trend, year, and seasonality. It also provides the weekly trend also, but it depends on what is the requirement of the project. Next one is the LSTM. The LSTM uses almost the same method as the previous two, but the main feature is that they build the feature set. That is, they take the lag requirement of the particular years, as we have taken the year from 2013 to 2021. They calculate the lag between each year, and we have considered almost 12 lags. And after that, scaling the data, they forecast the predicted value of the for the next 1 year. We will now see the what we have implemented as using this system, and our main we will also see some photos of the system in the next slides. But this is the overall flowchart, where administrator can log into the admin mode, and then there are two functions for it, where you can go and check out the forecasting values like models and forecasts. Model specific insights and model specific predictions are the two parts in the models, where the graphs are shown, and you can accurately see the forecasted value and the insight value for the particular model. While in the forecast part, manufacturer can see color-wise, region-wise model, and also the along with that we can see the regional part. Now moving to the results. These are the dashboard preview. As I said, we have implemented a system. Okay. So now the sales forecasting part. As I said, manufacturer can select the model, color, and region, and according to that, the prediction will be provided to him in the next in the paragraph part, where hovering over that he will get the exact values over whatever the region he has selected and the model he want to see. The prediction will be. Now coming to the conclusion part, it provides system predicts the sale for the future model to meet the continued demand. Since it was a prototype, we took only the one manufacturer as a Maruti and considered the 10 model only. And we tried using 3 different time series algorithms, ARIMA, FP Profit, and LSTM. FP Profit performed the best, like I said earlier, around 5% of error rate only. And the dashboard was built containing information with analysis. Like the graph, there are various graphs, not only as if I go to previous slide, you can see the one pie chart which is for the color wise and the bar graph for the region wise data. And our system name, we called it as Auto Envision, since auto for the automobile and Envision is for the future predictions. This is the overall idea of our paper review. Thank you.
Yeah, thank you, Deep. I have one question. Like,
Yes,
can you, can you make it generic, or will this
Yes,
model work in general, or it will be limited to only the specific models of specific?
No. Since it was for our prototype only, we considered as a Maruti, but it is generic. We can implement it on the various manufacturers, and according to their need, we can modify it also.
So in this prototype, what were the exceptional parameters you found? I mean, which have affected on this prediction values?
We found the patterns. Basically, if we consider the data from the previous 9 years, 2013 to 2021, the patterns we found was the exceptional parameter, if we consider for the forecasting part. And it also indicated the need for the customer. Like the previously around 2013, it was the sales was less, but right now it is increasing. If you can see. Yeah, so it's like basically the model learns from the pattern if what we provided. That is the main focus of the using FP Profit and giving the accurate predictions.
Thank you, Deepak.
Thank you, ma'am.
Now we can call our next presenter. DD Sapakal to present his paper on IoT cloud, convergence use cases, opportunities, challenges, comprehensive survey.
Is it visible? Hello, madam.
Yes, it's visible.
Yeah. Good evening, respected chair and the colleague presenter. My topic is IoT cloud convergence use cases, opportunity, challenges, comprehensive survey. My major contributors are Dr. R.V. Patil, Dr. Parikshit Mahalle, Satish Kamble. The outline of my presentation is introduction, motivation, literature survey, gap analysis, problem statement, methodology, proposed architecture, plan of research work, and conclusion, list of publication and references. As you all aware, the today's era is the IoT based area. By the year 2025, you will be seeing almost 80 billion IoT based devices. And to handle those many devices by the IoT device itself is very cumbersome, because IoT itself has the less processing power and the less memory. That's why we need to have the certain solution for that. So we need to go to with the cloud computing as such. Motivation, as I told you earlier, that the IoT devices has lesser capability of processing.
Sorry for interrupt, sir. Your PPT is not moving. You are still on first slide.
Let me see. Is it visible, madam?
Yes, PPT is visible, but you are on first slide.
Yeah. Can you see the motivation?
No, no, sir, no.
Let me stop it. Is it visible, madam?
Yes, sir, now it's visible.
Yeah. Thank you. So motivation towards this considering this problem statement is the less constraint of the IoT devices as such, having the lesser capacity, space, storage as such. And as I told you earlier, that the almost 80 billion devices will be attached to the system network as such. So to handling those many devices, it is very tedious. So there should be some sort of such solution as such. So I will be sharing those things in the next slide. Yeah, is it visible now, madam? The comparison literature survey.
Yes, sir. Yes, sir. It's
Yeah.
visible.
So as I have studied almost 40 papers, and from that I accept some papers in this literature survey. So here, the first paper, secure optimized load balancing for multi-tier IoT and edge cloud computing, having some sort of limitation as such that the security, the load balancing as such is not satisfactory. Same with the dynamic hierarchical access control IoT, where the access control is based on the time and the specific condition as such. So not handling those many access criteria. So the third one is the proposed volunteer supported fog computing environment for delay sensitive. In this, the good advantage is that the virtual machine and the other stuff, that is the computing stuff, are available at the edge, so that the request from the number of IoT devices can be handled effectively. But just I mean, there are the other aspects as well to consider, not only just seeing the load balancing as such. So the next paper, optimized data storage algorithm of IoT based cloud computing, handling the hash algorithm Hadoop distributed system. Basically the vast variety of data, and to store that data in an effective manner, maybe in the terms of encryption as such, or maybe the particular format. So for that, this particular paper talks about. The sixth paper, that is heterogeneous security information transmission algorithm for IoT-based cloud computing. This talks about the resource management, but lesser in the security aspects. So another next paper is the IoT cloud computing issue, challenges and opportunities, which also talks about the survey, and all the papers has certain lacunas regarding the security as such. So to deal with those things, the paper having the certain application protocol, I mean, that is used in the IoT and cloud computing interaction, that is constraint oriented application protocol and MQTT. This certain application protocol has the lesser capability. So I'll be talking those things in the coming slide. So the remedy of that, workload aware, another paper is workload aware VM consolidation method, which talks about the load balancing, but not the energy, saving the energy consumed by the devices. So these are the 8 papers which I studied thoroughly. From that, I found that certain things in respect to security, load balancing, data access, storage, data format, access control, and energy efficient. The first paper is only giving the security, load balancing, and the energy efficient, which is lacking in the data access and the data format storage. Even the access control is not that much available in this paper. Second paper, which gives you the security and the access control, but not other aspects. So if you see this particular 8 paper, there you can find there are the 2 fields, that is access storage and data format, and the access control. Majorly, these many papers are not providing. So why not to concentrate on this particular 2 aspect, that is access control and the data access storage, or the data transmission encryption as such. So my next criteria would be based on this particular things. So this is my first problem statement. First of all, need to consider the different use cases, in-house, indoor, outdoor, basically. So by studying those things, like this is mentioned in this taxonomy, IoT business use cases, indoor, certain applications are there, certain outdoor applications. And by studying those many applications and considering those previous papers, I found that I'll not discuss this IoT use case thoroughly right now, because I need to explain the other aspects which I found by studying these many use cases. So these are the limitations I found across by studying all those papers. The first is the standardization in data exchange format. There are lot many IoT devices, and every couple of devices having the different data format as such. So it is very difficult to handle those many data formats, because ultimately cloud computing need to process those data. So either you can convert this JSON or XML data in a particular format, or suggest the manufacturer to come up with the same style of or same type of IoT devices that can only handle the XML data. So accordingly, there should be some sort of standardization that to be followed by all the IoT manufacturers. Another limitation I see in in these papers, that is a lack of security in communication protocol, application protocol as such, like constraint oriented application protocol and MQTT, where this application protocol are using the external security encryption as such with the help of TLS and SSL. My point of thing here is that can it be possible to provide this security inside the application protocol like COAP and MQTT? So that there are the provisions available in the MQTT RFC. I have gone through this. Then other aspect is lack of access control strategy, which will control network traffic and authenticity. Another good point is that just imagine 80 millions of devices handling or accessing the cloud services. So it is very much difficult to handle those many devices. So can it be there certain sort of access policies, like context-based access given, or time-based access given, or any history-based access given? So we need to think, or we can combine these many access policies in the existing system. Another next limitation is selection of geolocation specific and ideal VM servers for appropriate load balancing. If you are dealing with the video processing as such, so there can be a certain virtual machine server that only handle the video processing or video, computing as such. So need to employ many virtual machine servers. The next is the enormous amount of data that are highly distributed, heterogeneous, decentralized, generated by real virtual IoT device need to filter. So as I told you earlier that so many IoT devices raising these different data types. So that data types or different data format need to be pre-processed, separate or segregate as such before uploading onto the cloud. If you are not uploading and just sending on to the cloud directly, so that the task of the cloud will, major time of the cloud or virtual machine as such is engaged just by converting the data format. So can it be possible in the IoT itself or certain application that can convert this data format in suitable form of the cloud computing? Then next is the absence of smart gateway communication depending on the data type. As I mentioned it earlier in the previous point that certain data types can be segregated or seeing the volume accordingly, and that to be routed to the particular gateway. Then next is storage encryption is used to provide better control over data, but it is not sufficient. So whether we need to follow the encryption in the cloud storage as such, or whether we need to encrypt the data over the transmission of the data. So which one is feasible? Need to think on that. Location, then next part, location, the data dispersed at different location and different formats in cloud. This is happening because there are a lot many virtual.
Sorry to interrupt, sir. So you have last 1 minute.
Yes, ma'am. Absence of fine. So I'll give the some sort of suggestions or some sort of methodology here to avoid such type of problems. One is the there can be making the provision in the MQTT itself, so that it will consider the encryption parameters. And the access control, that is I already talked about this: role based, history based, experience based, context level. And there should be some sort of unified data format, either XML or JSON. This is the proposed architecture involving the unified data format, energy level load balancing, access control and authentication, and encryption, which I told about the MQTT. The conclusion: the integration of cloud computing with IoT offers multiple advantages in terms of storage capacity, processing power, security in data storage transmission, effective utilization of resources, optimum power utilization, which in turn minimizes the carbon footprint. So our intention is to minimize the footprints, because carbon footprints basically, because there are a lot many engagement of the virtual machine, and that virtual machine are only doing the immaterial tasks, not doing the processing or computing as such, just converting one form into another and just segregating the data. So to avoid that, we need to employ such a system. So that's it from my side. Thank you very much.
Thank you, Mr. Vivek, for wonderful presentation. I have one question. Like, now see, when we talk about IoT use cases in different domains, so surely you'll come across with the constraint environment, right?
Yes.
So, I mean, what was your approach or your perspective? Like you said, the proposed thing can be now adding the security or encryption in the MQTT itself. So what is your view so as to make it compatible in the constrained environment? You need to go for some lightweight solutions.
Yes, madam. As you talk about the lightweight, MQTT itself is a lightweight protocol which will handle low power IoT. And if I include some security or encryption criteria in the MQTT itself, that will be overburden and that will not be called as a lightweight. But in the 256 bits of MQTT, there are some reserved bits. Can we use those reserved bits for the some sort of encryption criteria as such?
Okay. So have you done any analysis on that? I mean,
Yeah, just referred MQTT manuals. Currently, MQTT 5.0 I studied. So there are the provision, there are the possibility.
thank you, Mr. Gaurav.
Thank you, madam.
Now we can call our next presenter to present a paper on locating areas of crime against children with a K-means cluster algorithm.
So this is Srilasya Changalsetti speaking from Vellore Institute of Technology. I'll be presenting a paper on locating areas of crime against children with K-means clustering algorithm with my co-author Nitya Rajan. So we'll go over the introduction, literature, some of the papers that we took for reference, the methodology, how and the conclusion, our findings basically. So coming to the introduction, crime against children is a crime committed against any individual who is under the age of 18 years old. It can include sex trafficking of minors, child pornography, neglect, exploitation, and many more. But children who are so young, or especially basically child victims, they're not able to report or speak up against these crimes. Hence why it's very important and necessary to find trends on where these crimes are being committed. Hence we are trying to find such trends using K-means algorithm. So we took several papers for reference, but here are some that mostly guided us through this process. Most of them use machine learning and other algorithms in machine learning, such as K-means, DB-scan, and other data mining approaches. So the methodology we used was basically we took data from the National Crime Bureau of India of crime against children data set from 2016 to 20. And then the data set that we had a few gaps in them. So to fill in those gaps, we used data from the Aadhaar India States projected children population data set. Then we used the Excel file to clean up the data set, which we then used K9, which is a platform, to process this data. And we used the K-means methodology on it, applied it, and visualized the data and came up with our findings. So the K9 platform is a platform which enables us to analyze the data using a drag and drop interface, which makes it very easy because we don't really need coding. So that's what this is. And then now I let my co-author Nitya take over.
So I'll just briefly be explaining why we chose the K-means clustering algorithm. So a strong point about K-means is we can define how many clusters we want to create. And this is also an effect that we wanted so that we could classify various states into high risk and low risk areas. So the way it works is it builds a cluster of K groups on data points based on similarity, so using their Euclidean distance. And the centroid of each group is updated depending on all the data points, mean value in the group. So that's just a brief overview of the algorithm. Coming to our data set, so we took it from the National Crime Records Bureau, which has a data set on crime against children over the years 2016 to 2020. And we used the data over these 5 years from each state. After filling it out using data from the Aadhaar data set and cleaning it up, we were able to use this data set of 150 points after pre-processing. So this is then the K9 platform that we used. As you can see, K9 works by designing workflows. We first insert our data set using the CSV reader, then perform the K-means algorithm. And furthermore, we can then visualize the data using a scatter plot. So these were the results we got. On the one hand, you can see our results in the Excel sheet and also visualized in a scatter plot. So as I was saying, we wanted to classify the data into high risk and low risk areas. So we created 2 clusters, labeled cluster 0 and cluster 1. And you can see the distribution, the red being high risk and the green being low risk areas. So a bit more detail on our results. We created 2 clusters, low crime and high crime. Cluster 1 shows 7 states, namely Chhattisgarh, Goa, Delhi, Haryana, Madhya Pradesh, Maharashtra, and Sikkim. And these were all classified as high crime areas, whereas cluster 0 showed the other 23 states as being low crime areas. So some limitations on our study include the fact that we use the Euclidean distance metric, which pays attention to measure linear distance between data points, but the overall data set distribution structure is avoided. So outliers can drag these centroids around for the K-means algorithm. And we did have some outliers, for example, Delhi. Coming to our conclusion. So as we can see, machine learning techniques are becoming increasingly important in the field of crime analysis and can really provide us with a great way in order to work against crime, which is a growing problem. So in our study, we focus specifically on crime against children, and we also specifically use the K-means clustering algorithm. And we're hoping that the insights that we gained would be able to assist government officials on where they should be focusing in the future, where these high crime areas are, and using this data, they can create better strategies to combat crime against children. Furthermore, we also suggest for further work, future work, utilizing more localized and densely clustered data. So crime rates, for example, within the specific regions of a city and specific metropolitan areas, and experimenting with different clustering algorithms such as DB-scan in order to explore and locate these areas that have high crime rates against children for targeted action plans. So these are our references. I don't want to bore you by going through each one of them, but there's the Crime Records Bureau and a few other important papers that we reference. Thank you for your attention, and we are open to questions.
Thank you, Srilasa, for the presentation. I have one question, like how you have categorized, first of all, low crime and high. I mean, you have made 2 categories. So how and how many are there in each category? What all crimes you have considered in these each categories?
So we specifically focused on a data set for crime against children. And as my co-author explained before, this includes crimes such as trafficking, child pornography, and exploitation and negligence. And this is included in all the data points. So that is the data set that we used. As for the distribution, we had 7 high risk states and 23 lower risk states. Yes.
Okay, fine.
Thank you.
Now we can call our next presenter. So Neha Trivedi. to present her paper on machine learning prediction model to predict long-term survival after heart and liver transplantation.
So is my screen visible for everyone?
Yes.
Okay, so good afternoon, everyone. Myself, Neha Dwivedi, with my co-authors Nehal, Nandita, Prajot, Toshvi, and Rashmita from MIT College of Engineering are going to present on the topic machine learning prediction models to predict long-term survival after heart and liver transplantation. So these are the contents we'll be seeing in this presentation. So as organ transplantation is an important treatment for incurable diseases, the survival analysis method is an appropriate or basic technique to find out the influence of such an operation. Objective of this research is to present a methodology for predicting patients' best outcome after organ donation. The MELD score is currently used to guide the organ allocation decisions, but it has its own limitations in accurately predicting transplant outcome. So here we propose and machine learning techniques, specifically a multi-layer precipiton neural network model, to improve the accuracy of survival prediction for organ transplantation patients. So during this research, we have done a brief research background about, and we have come up with the literature survey, which is divided into two stages. The first part contains the survey paper related to patient survival undergoing organ transplantation. And the second phase basically consists of the comparison of several models of artificial neural network. And then we move ahead with the proposed statement. The proposed statement is to predict the survival prognosis of a patient after transplantation using multi-layer precipiton artificial neural network model. So the materials used in this methodology is the two types of data sets, heart transplantation data set and the liver transplant data set. In heart transplantation data set is from UNOS, a trusted US government network, and the data set contains data on waiting list registrations and transplant done in US from 1987 to 2018 with 15,580 samples and 133 columns. And the liver transplant dataset includes information on the patients in a particular region over the time, including death while awaiting withdrawals and censored patients. And it also includes data on the patients on the waiting list from 1990 to 1999. So methodology is used. We have used artificial neural network model. Through cognitive learning, an artificial neural network model can predict new sensations by forming neural connections from prior connections. And then we have used k-fold cross-validation. K-fold cross-validation minimizes bias caused by random sampling. To enhance the multi-layer precipiton neural network model performance and prediction, we use 10-fold cross-validation. Data splitting. So we have randomly splitted the data to 75 to 25%. And with the training set comprises of 75% of the data patterns and the test set comprises of 25% of data patterns. So in the study of ANN models for analyzing the heart and liver transplant data set, training via 10-fold cross-validation, accuracy was determined for each fold, and each model performance was compared utilizing performance metrics. And for this result, comparative graph performance measures are drawn. So the graph 1 shows the performance of multi-layer precipiton neural network model outperformed with 87.5% accuracy for a smaller data set of liver transplantation and 72.5% accuracy for heart transplantation data set. And the third figure shows the other performance measures of these algorithms like precision, recalls, and F1 score. So accurate medical prognosis improves patients' recovery using data mining techniques, PCA, and association rule mining. ANN is used in heart and liver transplantation dataset with 10 cross-validation and pre-processing to enhance long-term survival predictions. At the end, I would like to conclude this presentation that the use of ANN models can provide more accurate and precise predictions of long-term survival outcomes for patients undergoing organ transplantation, and the selection of relevant input parameters is crucial for achieving the best results. And lastly, I would like to thank everyone for paying their kind attention. Thank you. These were the references we took. Thank you.
Thank you, Neha, for the presentation. My question is, have you carried out this study in the Indian context?
Yeah.
So what are your observations?
For Indian context, we haven't went. We have only taken the UNOS data sets, but we can do it if we go ahead with the research more.
And is there any specific reason you have not considered?
Because the data sets were not available for Indian, and this were the trusted data set sources. So we preferred these data sets more over the Indians for now.
I mean, for both the cases, still the data sets are not available. That you mean to say?
So for heart transplantation, mostly it is not available. For liver transplant, we didn't researched about it.
Okay.
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 Yeah.
So now we can call our next presenter. To present is a paper on remotely accessed smart CCTV system using machine learning. SB Pokle.
Good evening, respected. Slide is showing. Good evening, respected organizer, madam, and session chair, madam. Myself, Dr. SB Pokle, professor from Ramdev College of Engineering Management, Nagpur, along with co-authors Apurva, Janvi, and Mahi. I am going to present our paper titled Remotely Access Smart CCTV Camera Using Machine Learning. I am audible, madam?
Yes, you are audible, sir. Please go.
Yes. These are the contents in our presentation, right from introduction, literature survey, market research, block diagram, application, conclusion, references. As an introduction part, we know that in the past few decades, surveillance cameras, also known as CCTV, that is closed circuit television, has gained a lot of importance because of the increase in the crime rate in the society. The peoples are more aware for the security purpose, and so they are installing the cameras. Now, smart CCTV cameras are being developed to make the monitoring process easier. They can be remotely accessed from anywhere, and footage can be viewed live or recorded for the future reference. Machine learning is used to detect abnormal behavior or suspicious objects that might be threat to the environment. The aim is to explore the feasible way to integrate both object detection and face recognition methods into commercial video surveillance systems by evaluating and experimenting state-of-the-art algorithms. So this is the main aim. And for this purpose, we have done some literature review, and we found a few important papers doing the research in this area, such as intelligence video surveillance, deep learning approach to building an intelligence video surveillance system, then IoT-based smart surveillance system using deep learning. So these are some of the research works the researchers are doing, and outcome of this literature review is mentioned over here. Deep learning technique is used in detecting the exact count, involved persons, and happen activity in the large crowd at all climate conditions. Then facial recognition and image capturing is successful in motion detection and alerting. They can even store data that can be indexed. They are successful in securing confidential areas. Many of them have used MATLAB to find textual information from video and can be indexed and used for search. IoT-based surveillance security system is best for detecting any movement occurring in the space. Deep learning algorithms can be used to identify signs of aggression and violence in real time, which filters out the irregularities from normal patterns. Even after this, we found some shortcomings in the work. They fall short on noise detection and face identification. They also lack counting the number of people visiting. They also cannot detect the stolen object from the frame. So in our work, we have tried to improve this system with these shortcomings. So problem statement is that we have developed the CCTV system which provides the wide range of features in order to solve following problems in the surveillance areas. The number one is count people entering and leaving the room. Number two, identifies known and unknown people and provides option of adding data known visitors. The third objective is that compares image frames to detect the stolen object. So objectives, if we summarize, the house will be closely monitored and CCTV installation will continuously monitor the neighborhood. It serves as caution to outsiders to refrain from any criminal undertakings. Organizations monitoring the locations and individuals become crucial for offices, schools, and other facilities to provide better care. It will keep an eye on both the internal and external guest activity. The thing may go missing frequently with no one knowing where it is. The recordings are available for a period of time, which is helpful in such trying circumstances. In addition to that, visitor records are accessible. If the proof of theft or loss of property is discovered, prior days videos can assist in resolving the evidence issues. With extra proof from the CCTV camera, which can help identify times, places, and most importantly, suspects, crimes can be solved much more quickly. The model is capable of performing functions like monitoring, identifying the known members with his or her name, noise detection, detection of visitors in the room, recording and detecting criminal activities. These are the market cameras, smart CCTV cameras available in the market, along with their prices are shown. The technologies used in the work are mainly the hard cascade classifier, then structural similarity algorithm, and a local binary pattern histogram algorithm for face recognition. Now, for hard cascade classifier, it is trained using thousands of sample photos, some of which include the object you wish to detect, while others do not. Hair features are typical traits that we observe in the majority of the human faces. These convolutional kernels used to find the presence of this feature in the given image are comparable to hair function. Then about structural similarity, it is a algorithm which is perceptual gauge that measures the reduction in picture quality carried on by data transfer losses or other processing steps like data compression. It is a complete reference measure that needs two images, a reference image and a process image from the same image position. Usually the edited picture is compressed. The third one is methodologies, local binary pattern histogram algorithm for face recognition. A person's position can be recognized using the spot recognition method known as LBPH. It is renowned for its effectiveness and for being able to identify a person's position from both the back and front and the side. Okay. This is the block diagram for work. That is the first part is the image processing part, the second is object detection, and third block is the face recognition block. Working of the block diagram. Input image is acquired by the model first of all. Then image is then sent for processing by the model. This is done in 3 steps: enhancement, image segmentation, and image transformation. The captured image is then sent for object detection. This is done by the following steps: object detection in the input image, detect the result visualization, detection results in RSU. The image is further processed for image recognition. Face recognition is performed on the input image. The results from the above steps is thresholding. Then the results are visualized. Then they are sent in archive. After all the above processes, the output image is sent on the display. The same cycle continues for all the real-time images. This is the GUI for the developed for the smart CCTV camera, in which the functionalities are shown: monitor, identify, rectangle, motion, in, out, and record functionalities. Details about the functionalities: monitor allows the detection of the what is being stolen from the frame. Identify least known members. The rectangle identifies the motion in a particular part of the frame. Motion finds the motion in frame. In, out recognizes who entered and left the room. Record, it is a normal sort of recording. So these are the functionalities in the project work. Working of the model. Monitor feature. This feature uses a structural similarity algorithm to detect motion by finding differences between the frames. Frames are captured when the noise is present and after the noise has stopped. So 2 frames are captured. SSIM is used as a metric to measure similarity between given images. The SSIM metric extracts 3 main features from an image: luminance, contrast, and structure. This system calculates an index of structural similarity between 2 given images, which is a value between -1 and +1. A value of +1 indicates that the 2 given images are very similar or identical, while the value of -1 indicates that the 2 given images are very different. Number 2, in and out function, a feature that can detect if someone has entered or left the room. It works using the following steps: the detection motion in the frame first. If there is a motion, it looks to see if it is coming from the left or right. Number 3, last check if the moment from left ends to the right. It is entered into the frame and detected as a capture, or vice versa. The captured image gets saved in and out folder respectively with date and time of the image. Number 3, identify the member. It is used to find if the person in the frame is known or not. This is done in two steps. Number 1, detecting the faces in the frame. This is done using hair cascade classifier built back into the OpenCV Python module. Cascading classifiers, also known as cascades of the enhanced classifier that operate with hair-like features, are a special case of ensemble learning, or known as boosting. Cascading classifier is trained on the hundreds of sample images that contain the object you want to detect and other images that do not contain that image. Second one, using LBPH for the face recognition. After detecting faces in the frame, next is to identify it and check if it is in the data set which we have used to train our LBPH model. LBPH uses 4 parameters. One is radius, then grid X, grid Y, and neighbors. Fourth function is detect motion in the rectangular frame. This feature uses contour detection.
Dear presenter, you may please conclude your presentation.
Yes, madam. To determine whether there is any motion or not in the particular rectangular frame. Then recording feature, we know everyone. And the 6th one is the motion. This function is used to detect motion in the frame. These are the results obtained. Results obtained after the code simulation are as follows. Monitoring function, whether it detects whether the object is stolen or not. After there is motion detected in the frame, the system waits for 2 seconds and takes another snap. Then it compares both the frames using structural similarity and makes a beep sound if the frames are not similar. So it prints the image similarity. Second one, the in-out, result for in-out function. It detects the direction of motion of the person and prints to the right or to the left accordingly, as shown in the images. Third one, identify. It identifies the face of the person, as shown in the frame, and name also detected if it is available in the database. Rectangle, it is used to detect motion in the particular selected region, as shown in the image. And motion, this function is used to detect motion in the frame, entire frame. Record acts as normal CCTV for recording purposes and save the recording with date and time. These are the various applications. It can be used, the system can be used in traffic monitoring, human motion detection, security purpose, home surveillance, availability of the huge data in video frames, reduce labor in the video surveillance scenarios, minimum error in movement detection. In conclusion, it is an excellent tool for home protection and it can work both as a deterrent and recovery tool. The action can be taken within short span of time in case of emergency conditions, such as military areas, smart homes, offices, industry, jewelry shop, etc. The task of CCTV is to determine the number of people found in the area and their position in order to obtain accurate information on part of recipients. The task of video surveillance is to determine number of people entered in that particular area or left that area in order to obtain reliable information from the receiver. Accuracy of the algorithm used in this project is about 96.24%. This system proves to be time efficient as compared to conventional CCTVs, as it is providing all the things we require at one place. Face recognition is the main part of the security system. Usually for best face recognition system, we require a well-trained database which can provide the base for the recognition. So to obtain database, we first collect the images of the subject individual for recognition. And once we obtain images, we train our system so that we can provide face recognition. In the future scope, the system can be can be added with adding alarms to get the alert from the criminal activities, then adding inbuilt night vision capability, creating portable CCTV, accident and fire detection reasons, then use on drones, deterring vandalism. And these are various references. Some good references are mentioned over here, right from Springer publications and some conferences also. Thank you very much. If you have any questions.
Yeah, thank you, sir, for the presentation. My question is, what were the values of FAR and FRR?
Yes, sir.
False acceptance and false rejection for this.
What are the, can you repeat the question, madam?
Sir, I mean, what was the percentage? Like the person is falsely accepted and the falsely rejected. So FAR, false acceptance and false rejection.
Yes. The accuracy of the system is 96.4%. So it is approximately.
Okay. And what were the main reasons for that?
The reasons are that the database is very huge and many people are entering the frame, suppose at a time in the crowded places. So some frame may be missed, and that's why the around 4% error may be there only.
Okay, sir. Thank you.
Okay.
Now we can call our next presenter. It's Aryan Dalal to present his paper on using blockchain smart contracts to regulate forest policies.
Is my screen visible?
Yes, your screen is visible.
Good evening, everyone. I'll be presenting my paper. My name is Aryan Dalal, and I'll be presenting my paper titled Using Blockchain Smart Contracts to Regulate Forest Policies. So this paper explores the implementation of blockchain algorithms using the Ethereum platform and the Solidity programming language for the management of forest policies, including the Clean Water Act and the Sandalwood Act 2022. Now, the use of smart contracts can help automate the compliance checks for these policies and ensure that all parties are adhering to the terms outlined in the acts. The deployment of this technology helps improve the implementation and monitoring of these policies by decentralizing the system of record keeping, reducing the complexity of the current system, and providing a secure and transparent record of all transactions. So it can increase transparency and accountability, reduce administrative overhead, and also improve data security in the management of these policies. And the main reason why I chose to write a paper on this topic was because I worked in forest conservation efforts at the Sanjay Gandhi National Park in Mumbai for a few years, and while over there, I realized that there's a lot of illegal activities regarding smuggling of trees and forest products that takes place, and there's not really any set structure, any system that can prevent that. And also, there are many problems with physical transactions in complying whether in checking whether everyone is complying with the regulations. Now, the two acts that will be talked about in this paper, the Clean Water Act and the Karnataka Sandalwood Policy. Now, each of these layout regulations are standards of procedures that must be followed to ensure compliance with government laws. For example, the Sandalwood Policy standards of procedures involve correctly identifying sandalwood trees, periodically monitoring their populations, and providing secure resource access. Now, physical transactions involved in complying this in checking the compliance of these can involve many cases of fraud and loss of data. The process can be very lengthy and costly due to there being huge amounts of paperwork. Now, the advantages of blockchain algorithms are that they make the transactions more reliable and transparent. All the data recorded in the blockchain technology is encrypted and immutable, and so much safer and less prone to hacking and fraud. Now, the methodology. So currently for the Clean Water Act, the physical transactions involve granting permits to permittees based on some conditions agreed upon by the Environmental Protection Agency or the EPA and the owner. During official checks, the EPA inspections occur following a review of the previously granted permit as well as cross-references of the same terms in the permit. Now, the decision of whether or not the permit should be granted is made by the investigation team. The smart contracts discussed in this paper were created using the Ethereum environment and then programmed using the Solidity 0.8.7 programming language, all compiled in the Remix IDE. So the transactions between the two parties will take place via the Ether currency, which are then validated and updated throughout the Ethereum environment by users mining puzzles carried out by the Ethereum virtual machine. Now, the smart contracts will be twofold, one of which will replace the permit being granted, while the other will be for the investigation team. The two will communicate together to verify the reviewed terms, automatically finish the transaction, and then store it in the encrypted blockchain. So some of the parameters that must be met to grant the permit are temperature, dissolved oxygen levels, pH level, conductivity, oxidation reduction potential, and turbidity. So the code in the smart contract first sets a structure of parameters to store different variables for the different parameters of clean water. Then an object named limit is created to reference these parameter variables, and each variable is assigned a value by the Clean Water Act. A function is then created to reference this limit to the structure. After this, there are still two other conditions that need to be fulfilled to grant a permit. Firstly, the source of the water needs to be an authorized point source, and also the discharge location of the water needs to be authorized. Another structure is created for the two Boolean variables to authorize the source and the discharge point, and a reference to the structure is created with the name conditions. And then following this, a function assigns the variables with appropriate true or false Boolean values once the source is verified. Since the conditions of the permit have been set, all that is left is for the permittee to transfer the permit fee to the EPA. Thus, if all conditions are met, the permittee is granted the permit and the fee is paid to the EPA. Now, a proposed methodology for the Sandalwood policy involves a smart contract, which is similar to the one created for the Clean Water Act. This contract could track all the existing sandalwood trees from the source to the manufacturing plants and would typically include details such as the sandalwood's origin, date of harvest, and the ownership history. Using blockchain for this process would automate the entire transaction, removing the need for an intermediary and therefore reducing risk of fraud, data loss, etc. Now, preset conditions such as scent, age, weight, burning, and color would serve as a form of a quality check, and the contract would validate the transaction only if the minimum requirements are mentioned in the conditions are met. So the first step would be to create the contract, which would be written in code and then deployed to the blockchain network. This would include all the terms and conditions for the tracking and management of sandalwood. Then data input, information about the sandalwood, such as the previously said origin, date of harvest, and ownership history, is recorded on the blockchain and stored in the contract. The contract is then programmed to automatically execute when certain conditions are met. It also automatically verifies and executes the transactions and records the information on the blockchain. Now, this is all tamper-proof because since the blockchain is immutable and encrypted, the recorded information cannot be altered, thus providing a very transparent and concrete record of the sandalwood's history. Furthermore, accessibility, all parties involved in the supply chain have access to the information stored in the contract, allowing for greater transparency and collaboration. Finalization, the contract can be set to automatically finalize when all the terms and conditions have been met, such as the delivery of the sandalwood to the buyer. In conclusion, the use of blockchain technology provides a secure, transparent, and convenient method to ensure compliance with government laws, such as the Sandalwood Policy and the Clean Water Act, to grant permits when compared to physical transactions. By improving the implementation of the Sandalwood Policy, the smart contract can enhance the benefits that arise from it, such as creating more jobs as well as providing additional income to farmers. Furthermore, it can incentivize farmers to practice sustainable harvesting, which will reduce deforestation. Additionally, it will also help the environment by preserving such a valuable natural resource. Now, the smart contracts, when used for the Clean Water Act, minimizes any external unneeded efforts and completely excludes any parties other than the EP and the permittee, recording all the data and storing it in an encrypted state. Secure blockchains are created which cannot be altered, with thus in both increasing transparency and safety. Now, the smart contracts that were discussed in this paper are not limited to only the Clean Water Act. The basis of the smart contract can be used to help any other forest policies, and Sandalwood Policy and Clean Water Act are just two mediums or examples to demonstrate the advantages of blockchain technology. The database created by the smart contracts can also be accessed by future investigations. A future scope could be to use AI and machine learning algorithms by implementing them in this database to analyze patterns of heavily investigated bodies of water throughout the USA, or to analyze other policies such as the Sandalwood Policy. Now, these are some references. And thank you.
Yeah, thank you, Aryan, for the presentation. My question is, have you implemented anything in this regard, or is it just a theoretical study?
So I did create like a code and a blockchain using using these parameters, the temperature, dissolved oxygen levels, which are all provided by the EPA. So it's really only a prototype at this point, but the results that I got really showed that it's much better than the physical transactions that are done to grant the permits.
Okay, thank you, Aryan.
Thank you.
Now we can call our last presenter is Chaitanya.
Yes, ma'am.
You may please start your presentation.
Thank you. Is the screen visible?
Yes, it's visible.
Thank you. So, good evening, everyone. I am the presenter. I'm going to present our paper comparative study of a transformer and LSTM network with attention block on the topic image captioning. So this will be our agenda for the presentation. So let's start with the introduction. What is image captioning? Image captioning is basically an idea of textual description of images. So basically we need a system which can understand the contents of the image, and we have to generate grammatically correct captions to describe what are the contents of the image. So this task involves the combination of two different fields in computer science. The first is computer vision and the other is NLP, that is natural language processing. So now let's see what has been done earlier in this field. There have been different existing models. Some of them have been non-deep learning models also. Non-deep learning models like multiple instance learning, graph-based GCAP model, and other models have been trying to solve this problem of image captioning, but we achieved a very low accuracy in our early days. So the other models were RNN LSTM model. The RNN LSTM model suffered the problem of gradient vanishing problem. This problem occurs due to the basic structure of RNN LSTM. So we have used two models in this study and we have compared them. The first is LSTM with attention block and the second is the transformer model. Both of these models have been very popular in this field of image captioning. The evaluation matrix we used was blue score. Let's see what was the dataset used. MS COCO dataset was used, MS COCO version 2014. This dataset consisted of 13 GB of training images and 6 GB of validation images. To give an insight, it accounts to almost 86,000 training images and 40,000 validation images. These dataset includes images of real-life objects, people, scenarios like street, apple, bathroom, anything. Images were annotated with 5 captions for training. These annotated captions would train the model to understand what were the contents of the images. Now let's see what were the processing techniques used. So as you can see, this was a very huge data set. We have a lot of objects around us and the model needed to be trained for a lot of objects. So this data set was trained on AWS. We used the GPU instance G4DN X large from the AWS. This GPU consisted of 4 vCPUs and with almost 16 GIB memory. Both models were implemented on the TensorFlow platform. Now I would like to pass on the presentation to Pranav.
So hello, I'm going to discuss about the methodologies which we have done in the paper. So the CNN model, transformer architecture, LSTM architecture, and evaluation. So coming to the CNN. So in this study, we have used the same CNN model for both transformer and LSTM network for the feature extraction. So this, which is the Inception V3 CNN model, which is a powerful CNN architecture that is widely used for a variety of computer vision tasks, including image captioning, image classification, object detection, and segmentation. So the feature extracted are stored in the NumPy files, and the main idea is this is done using the inception blocks that takes multiple filter of different sizes in parallel to capture the feature of different scales. Coming to the transformer architecture. So transformer address the issue of vanishing gradient problem that occurs in traditional RNNs and CNN models when processing a lengthy text input. So the main components of this transformer models are encoder decoder, and both of these encoder decoder uses the multi-head attention mechanism. So the encoder and decoder it makes the transformer fully attentive model. So the input which is produced by combining the input embedding and positional encoding, this combination is sent to the encoder part. This create attended representation with contextual information of each words. So the decoder contain an extra layer with compared to the encoder, which is the masked attention layer, which makes sure that the future words which are not taken into consideration while making the prediction. The third is the multi-head attention. In multi-head attention, the input sequence is first linearly projected into multiple heads, with each head having its own sets of weights. So this projection are then processed using a scale dot product attention, and then hence the attention scores are computed. Coming to the LSTM network, so its core architecture of a LSTM network is comparable to that of the RNNs, but it has a repeating module design, and that makes it different. So the structure have cell states, and the information to be preserved passes through the structure called gates. While making the prediction, the attention mechanism in LSTM is the method used to direct the network's attention on a specific portion of input sequences. Coming to the evaluation metric, we have used evaluation matrix named Blue Score, which is determined by how many n-grams is generated and the references text overlaps. So the n-grams can be in a range of 0 to 4. So the Blue Score gives the value between 0 to 1, 1 representing that the predicted caption and the reference captions are identical and have much more similarity. Coming to the discussion section, there have been, although we have used a vanilla transformer in this and LSTM attention networks, there have been several modifications made on transformer through and after 2014. So few of these we have listed and we have discussed in the paper. They have showed a state-of-art accuracy in generating the captions, such as M2 transformer, which have encoding decoding layer that are connected in like a mesh-like structure weighted by learnable gating mechanism. So they have showed a Blue Score 1 of 81.6. Similarly, clip diffusion model also, like diffusion model diffuses information through latent space over time. And in this paper, they have successfully applied diffusion probabilistic model to image captioning.
So now let's see what were the results of our study. Let's see the comparison part. The basic comparison was the transformer model outperformed the LSTM with attention block model with comparatively a larger gap. The training accuracy and validation accuracy of the transformer model were much more than the model of LSTM with attention block. If we are to consider the numbers, the Blue Score comparison, what we had achieved was 0.45 for the transformer model and 0.3 for LSTM model. So now at the end of the slide, you could see an image of a cake placed on a plate, and the predicted caption by our model was chocolate cake inside of a display on a table. So now you could see a bit of a grammatical mistake, but it perfectly identified that it was a cake and it was on a table. So now let's conclude our presentation. In the conclusion, I would like to say that transformer and LSTM with attention block model that was studied in this were both independently performing. Here we use the same data set, that is the MS COCO data set. These models were based on the same encoders, that is the Inception V3 CNN. The result showed that the transformer outperformed LSTM attention model. We have also seen that there has been some advancement in the technology, and different models like clip diffusion, X linear attention, and M2 transformer have shown the state-of-art accuracy for generating captions and have been much better with latest advancements. So here with this, we come to the end of our presentation. Thank you.
Yeah, thank you, Chaitanya, for the presentation. My question is, what could be the enhancement in this? I mean, is there anything which is not tackled yet?
Ma'am, the thing is, image captioning has a wide variety of applications, like wherever humans networking or human engagement has to be avoided. We need something that could describe what it is seeing. Like we could place a camera and we could understand what the camera has seen. So we don't need to monitor something for 24/7. So now for this, there has what we have studied were two models that were pretty complex, but those were models that were made for before 5 to 10 years. In the recent advancements, as we have already mentioned, there have been models like clip diffusion, X-linear attention. These models have shown the state-of-the-art accuracy. Like the models which we have studied, these models are much better than those models also. So research is needed on these models also, and with increasing the number of data set as the real life objects are infinite. So we need a huge data set to process all these objects and predict what computer vision or what is actually in front of the camera or the image.
Okay. And as you shown the last image as a result, so that you mentioned like there can be some grammatical mistake. So any other method or solution approach you have come across for this?
So ma'am, basically the task of image captioning involves both computer vision and natural language processing. So the natural language processing part, as mentioned in one of the model, is the LSTM part. So with some things like syntactical training or grammatical training, this thing could be improved. But the main part is to identify what is in front of the camera or what is present in the object. Sometimes syntactical or grammatical mistake can be there because of the framing of sentences, because the model trains on a lot of images. So sometimes the predicted or the reference captions can also be wrong. So the model trains on the wrong captions also.
Okay. Okay, Chetan. Thank you so much.
Thank you.
Now we had completed all the presentations. I sincerely thank our author for the excellent presentation and contribution in this session. All our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 7th version of and the previous 6th version of the conference. We will be happy to have you in the 8th version in 2024. All the presenter would be getting digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS. And I also thank our chair of this session, Dr. Swati Nikam. Thank you so much, ma'am, for your valuable time and your presence. This is a token of appreciation on behalf of the team of ICTIS and GIA Foundation.
Thank you so much. Thank you.
And I have one more request to everyone. Please turn on their cameras for taking a quick snapshot for making this virtual conference more memorable. Thank you so much, everyone. Thank you so much, ma'am.
Thank you.